Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General Class. This episode goes over sub-element G1, Group C of the Commission's rules, and I'm your host, Ron Call, KE7CR. This section deals with transmitter power and emission standards and 60-meter band operation. So let me show this chart, the U.S. Amateur Radio Bands chart. I've told you about it in a previous podcast, and this has the answers to the power levels for several of the questions in this section. Notice it says, no station may transmit with a transmitter power exceeding 1.5 kilowatts PEP. The maximum power limit of any amateur radio station is 1.5 kilowatts, 1500 watts, peak envelope power. Now, some bands and some sections have less than that, but that is the maximum. If it's not specified on a particular band, that's the maximum. Notice on the chart, 30 meters says 200 watts PEP. Now notice it also says an amateur station must use the minimum transmitter power necessary to carry out the desired communications, but in no case can you exceed 1500 watts PEP. Question number 1 asks, what is the maximum transmitter power an amateur station may use on 10.140 megahertz? Well, that's in the 30-meter band, so it's 200 watts PEP output. Question 2, what is the maximum transmitter power an amateur station may use on the 12-meter band? Well, it's not 30 meters, so 1500 watts. Question 3, what is the maximum bandwidth permitted by the FCC rules for amateur radio stations transmitting on upper sideband frequencies in the 60-meter band? And 60 meters has a little notation, 2.8 kilohertz for a bandwidth. Normally, single sideband, we think of them as occupying about 3 kilohertz of bandwidth, but you can get by with a little less, so just remember it's just slightly less than 3 kilohertz. It's 2.8 kilohertz, just slightly less than 3 kilohertz that we normally think of as the bandwidth of a single sideband signal. Which of the following is required by the FCC rules when operating in the 60-meter band? The chart also says for 60 meters a maximum effective radiated power of 100 watts PEP relative to a half-wave dipole. If you're operating with the half-wave dipole, then you're fine. If you don't have a half-wave dipole and you have some kind of other antenna, you need to keep track of how much gain that antenna has relative to a half-wave dipole. Say your antenna has a gain of 2 relative to a dipole, then you really could only operate with 50 watts PEP, because with a gain of 2 that would be equivalent to 100 watts PEP with a half-wave dipole. The answer to that question is, if you are using an antenna other than a dipole, you must keep a record of the gain of your antenna. Question 5. What is the limit for transmitter power on the 28 megahertz band for a general class control operator? Again, 28 megahertz, 10 meters, it's not 30 meters, so it's 1500 watts. The next question also asks about transmitter power, this time on the 1.8 megahertz band. 1.8 megahertz, that's 1500 watts PEP output also. The next question asks, what must be done before using a new digital protocol on the air? Now, amateur radio operators are often developing new digital modes. So the rule is, before you can operate using a new digital protocol on the air, the answer is publicly document the technical characteristics of the protocol. That's all that's required. Next question. What is the maximum symbol rate permitted for RTTY or data emission transmitted at frequencies below 28 megahertz? Because data rate is tied to bandwidth, different standards exist for different bands of frequencies. Anything below 10 meters, you're limited to 300 baud. 10 meters is 1200 baud. 6 and 2 meters is 19.6 kilobaud. 1.25 meters, 70 centimeter band is 56 kilobaud. 33 centimeters and above, there's no limit on the symbol rate. Now, the baud rate is similar to the bit rate. Some people are more familiar with bits per second. Baud just means the symbols per second. Now, a symbol might be more than one bit. Depends on the mode, how many bits are in a symbol. But that's what the baud rate is, how many symbols per second. So just remember the answer to this question, since it's below 28 megahertz, so it would be below 10 meters, the answer would be 300 baud. The next question, what is the maximum power limit on the 60 meter band? The effective radiated power of 100 watts peak envelope power with respect to a half-wave dipole. Next question, what is the maximum symbol rate permitted for RTTY or data emission transmissions on the 10 meter band? Again, 10 meters is 1200 baud. Last question, what measurement is specified by the FCC rules that regulate maximum power? So the measurement that we do for power is PEP, peak envelope power output from the transmitter. And that's all there is in this section. Thanks for listening, and we'll look for you in the next section. This is KE7CR 73.